Hello guys, welcome again to module 5, which entails object-oriented programming. In this module we are going to cover 6 sections, and section 1 will include classes and objects, section 2 constructors, that is underscore init underscore and destructors. Part 3 we are going to look at instance versus class versus static methods, and part 4 we are going to look at inheritance and polymorphism. Moving ahead, on part 5, we're going to look at encapsulation and abstraction. And finally, on part 6, we're going to look at operator of loading, that is underscore add underscore and underscore star underscore, among other methods. Yes, guys, this module 5 will entail object-oriented programming, that is OOP, with expanded edition, and we are going to look at a comprehensive guide to object-oriented programming concept with detailed explanations, multiple examples, and practical applications for beginners. So we're going to start with classes and objects. What are classes and objects? So think of a class as a blueprint, as a plan, as a design, as a template, as a roadmap for creating real objects. An object, for example, is a specific instance created from that blueprint, and this blueprint can create objects such as buildings, cars, roads, among others. So, real-world analogy of a class can be compared to a cookie cutter, whereas an object can be compared to actual cookie. So we have key concepts about this module. We're going to look at attributes, and which will entail variables that belong to an object or a class, and methods are just functions that belong to an object or a class. And we have also a self parameter, which refers to referring to the current instance. So we want to look at basic class definition. And I hope I'm not rushing. You're getting each and every step. So when we write a class, you define the general behavior that a whole category of objects can have. For example, making an object from a class is called an instance, and you work with instances of a class. So in this chapter, you will write classes and create instances of those classes. So you will specify the kind of information that can be stored in instances, and you will define actions that can be taken with these instances. Again, you will also write classes that extend the functions, that extend the functionality of existing classes. So similar classes can share code efficiently. Moving ahead, you will also store your classes in modules and import classes written by other programmers into your own program files. And understanding object-oriented programming will essentially help you see the world as a programmer does. So it will help you really know your code, not just what is happening line by line, but also the bigger picture or concept behind it. So knowing the logic behind classes will train you to think logically. So you can write programs that effectively address almost any problem you encounter in this world. So classes also make life easier, not just for me, but for you and the other programmers. So you will need to work with as you take on increasingly complex challenges. So when you and other programmers write code bases or code based on the same kind of logic, you will be able to understand each other's work, and your programs will make sense to many collaborators, allowing everyone to accomplish more. So we are going to create and use our classes. So for example, you need to remember that you can model almost anything in this world using classes. And our first example will be animal class, and each instance are created from the animal class will store a name and a species, and we will give each animal the ability, for example, to speak and feed. For example, our class instance is animal, so base class, yeah, animal is a base class for all the animals that we have to create. For example, dog, cat, etc. So for example, kingdom animalia, kingdom is equal to animalia. So this is the same for all animals, or will be the same for all the animals. So, and the init method is the function that is part of a class, and we need to define the init method using self, name, and species. So the def in underscore init underscore is just a constructor for our class, and it's only called when creating new instance. So we initialize the name and species attribute using the init method. So the instance attributes are just unique to each other. For example, self.name will be name, self.species will be species, and self.energy will be, for example, 100, so which will be default value for all new animals. So moving ahead, so we define the init method, or underscore init underscore method, to have three parameters, that is self, name, and species. So, and the self parameter is required in the method definition, and it must come first before the other parameters. Therefore, it must be included in the def or the definition, because when Python calls this underscore underscore init underscore underscore method later to create an instance of an animal, the method call will automatically pass the self argument. So the animal class has two other methods that are defined by speak and feed. So we also have a def so the method of speak, for example, it's also checking the parameter, the argument as self. So inside the method for all the animals can speak. So and you can return self dot name. So and return the sound of the animal. So you can also define the feed. So which means an animal can feed food. So and the method can be modified to make our instance a state. So for example, self.energy, we are incrementing it to food amount. So let me deal with my indentation. We want to create an instance of classes or instance from classes. So we can think of a class as a set of instructions. So we are just doing some recap of what we've learned previously for how to make an instance. So the class animal in this example that we used is a set of instructions that tells Python how to make individual instances representing the specified animals. For example, lion is equals to animal Simba, and the scientific name is Panthera leo, for example. And dog is equal to animal, it can be called Buddy, and is from scientific name Canis familiaris. So we want to access the attributes and methods. So to access the attributes of an instance, you have to use dot notation. So we access the value of animals attribute name by writing, for example, print lion.name, that is will be Simba, and dog.species will be, the output will be Canis familiaris, and the lion.speak will be Simba makes sound, and dog.feed 20, for example, the output will be the body ate and has now running our code by ops.py, and we realize that the first output is Simba, that is lion.name Simba, dog.species familiaris, lion.speak Simba makes a sound, and dog.feed body ate and now has 120 energy, and all of stuff are just being originated from this line of code. So Simba, that's lion, has a parameter of a name and a species. So and the same dog has the name body and species name as Canis familiaris. So I hope this is making sense from this function, from this class body, that the our class method has three parameters, that's self, name, and species. So remember, this one is just a method. A method is something that defines your behavior, like behavior for human beings, that this human being can run, can walk, for example, can speak, can eat, among other behaviors. So a function's method is just to define the behavior of a class. So for example, the behavior of this Simba is that it can make a sound. The behavior of our bird, which is the dog, is that it can eat and it has some energy. Yes, that is it. So just move ahead. So we're moving ahead on section 2. We are going to look at inheritance and polymorphism. So we've looked at classes. So we're looking at polymorphism and inheritance. So inheritance allows new classes to inherit attributes and methods. I believe now at the moment we understand methods are just behaviors, and attributes are what are contained within the class. So from existing the attribute and method from existing classes. So this will promote code reuse. So polymorphism allows objects of different classes to be treated as object of a common superclass. So we need to look at basic inheritance example. So, and remember, you don't always have to start from scratch when writing a class, and if the class you are writing is a specialized version of another, that's of another class you wrote, then you can use inheritance as an alternative. So when one class inherits from another, it automatically takes on all the attributes and methods of the first class. So for example, you've inherited the behaviors of your great-grandfathers or great-grandmothers or great-grandparents in short. So the original class is called the parent class, and the new class is called the child class. So you can inherit the properties of your parents, or the properties of your great-grandparents. So the child class always inherits every attribute and method from its parent, but it's also free to define new attributes, which means it can add on new attributes apart from what it inherited from the parent class. So subsection 2, we are going to look at inheritance and polymorphism. So remember, inheritance allows new classes to inherit attributes and methods from the parent or the existing class. So, and this promotes code reuse. Remember the drive principle, don't repeat yourself. So polymorphism, on the other hand, allows objects of different classes to be treated as objects of a common superclass. So we need to look at basic inheritance example or scenario. So remember, you don't always have to start from scratch when writing a class. So if the class you are writing is a specialized version of another class, then another class you wrote, then you can use inheritance. Alternatively, when one class inherits from another, it automatically takes on all the attributes and methods of the first class, which I can say the parent class or the original class. So the original class is called the parent class, as I've just said, and the new class is called the child class. So the child class will inherit every attribute or aspect and method from its parent class, but is also free to define new attributes and methods. So which means it is scalable, that you can add new features in future. So the init method for a child class can be documented as follows. So the first task Python has when creating an instance from a child class is to assign values to all attributes in the parent class. So to do this, the init method for a child, that is for child class, needs help from its parent class. As an example, let us model an electric car. An electric car is just a specific kind of a car, so we can base our new electric car class on the car class, and we are about to write it. So then we'll only have to write code for the attributes and behavior specific to electric car. So let's start by making a simple version of the electric car class, which does everything the car class does. So let us start with step 1, and we're going to look at our car class. So this is a simple attempt to represent a car, and we're going to define our method with attribute as self, make, model, and year of make. So self.make is the make, self.model will be model, self.year will be year, and self.odometer reading, let it be 0. So we can define the description of our car to be self, and long name to be like star self.year plus self.make plus self.model, for example. And we can also return the long name dot title, and you can also define the odometer reading as self. And then you can also print this car has, for example, star self.odometer reading plus miles on it. So we can also define updated odometer as self and mileage. So, and if mileage is greater than or equal to self.odometer reading, then self.odometer should be updated, so which means is equal to mileage. Else we need to print we need to tell the system that you can't back an odometer. So define an increment of odometer. So it will take two parameters, self and miles. So self dot mile self.odometer reading plus is equals to plus miles. So in step 2 we're going to do at class electric car, which means electric car is inheriting from car. So I'm having indentation issues, but I'll have to fix this later. So we can define init method with attribute as self, make, model, and year. So we want to initialize the attributes, and please make sure to pause the video if I'm going very fast. So super init method. So we can have make, model, and year. So the last step, we're going to now to initialize our class instances, or from the we can say the object instances from the class. So my Tesla, for example, is equals to electrica Tesla model and the year 2006. So, and you can also print my Tesla.get descriptive name, and we'll get the name as follows. So let me fix first of all the indentation issues, and then run our code. So printing our class, let us see the output. So pi ops.py. So we find out that the output is 2016 Tesla and Model S. Now let us just summarize what we've just done. So at step 1, so make sure to pause the video and return to step 1. So we start with the car. So when you create a child class, the parent class must be a part of the current file and must appear before the child class in the file. And at step 2, we have defined the child class, that is electric car. So the name of the parent class must be included in the parentheses in the definition of the child class. So, and the init method at step 3 takes in the information required to make a car instance. And the super function at step 4 is a special function that helps Python make connections between the parent and the child class. So this line tells Python to call the init method from electric car's parent class, and that is a car, which gives an electrica instance all the attributes of its parent class. The name super comes from a convention of calling the parent a superclass and the child class a subclass. So we also test whether inheritance is working properly by trying to create an electric car with the same kind of information we had provided when making a regular car. So, and at step 5, now we make an instance of the electric car class and store it in my Tesla. So this line calls the init method defined in electric car, which in turn tells Python to call the method, that is init method defined in the parent class car. We provide the arguments Tesla, Model S, and 2016. Hello guys, let's have our example 2. So our cat will inherit from our animal class, which is the parent class, as follows. So class cat into bracket animal, and we define that the cat can speak, which means we are giving it a method, and we can return that set.name, which means the name of the cat says meow. So, and we can also define that the cat can can nap and can also add some energy during that time of napping. And you can also print that return self.name napped and gained these hours. So guys, let us have another example of inheritance, and that is a dog, which will also inherit from the class animal. So we have now two animals under animal class, dog and cat. So we can define the method for cat still also name and breed, for example, and now it wants to inherit from the main class, and we call the parent constructor. So self.breed is equal to breed, and self.name will be still the name. Hi guys, let us look at method overriding at this dog class using polymorphism. So we can define that the dog can speak, and you can understand that self.name says hoof, which means the name of the dog, it says hoof. So, and remember that this speak method overrides the one from the animal class, providing behavior specific to the dog class. Now we're going to look at new methods specific to our dog class. So you can define that the dog can fetch something, so self and item. So the dog can fetch an item. So self.energy is equal to minus 10, which means after fetching the energy, the item, which means some energy will be wasted or used. So this method allows a dog instant to fetch an item, and each time it fetches the item, it consumes 10 units of energy. Now let us create the instance of our object, or of our classes in particular. So for example, body is equal to dog, and this dog's name is body, and it is golden retriever. So whisker is equal to cat, whiskers, comma, felis cutters. So you can use polymorphism as well. So for example, pet is equal to body and whisker. So for pet in pet, we can print pet dot speak, and the output should be body says woof and whiskers says meow. Therefore, we can also use specialized methods, such as now we want to print by using dot notation, print body.fetch ball, so which means the body fetch the ball as we had designed previously. So print whiskers.nap 2, which means it took like 2 hours to take a nap and gain 10 energy. Now guys, let us review our code from the top to the bottom. So we have class animal, and now we have subclass cat, and we have also subclass dog, and each subclass has specific method. For example, a cat can speak and can take a nap. Likewise, a dog can speak and can also fetch an item. So now we can create instances of both subclasses. Now we can also use polymorphism to manipulate our class instances. And finally, we can now print to get our final output. So let me print out and see the outcome if they match. So py ops.py, and you find out that body says hoof, whiskers says meow, and body fetched the ball. Whiskers napped and gained 10 energy. Hello guys, in this subsection 3 we're going to look at encapsulation and its properties. So you need to remember that encapsulation is a way to protect an object's internal state by restricting access to some of its properties or components. You can have a bank account as an instance. So I will demonstrate how encapsulation does with the private attributes. So for example, we want to define some methods, self, owner, and initial balance as defaulted to 0, and self.owner is equal to owner. So we can also do self.balance is equal to initial underscore balance. This one is a private attribute, and the name the owner can only access such. So we can also define at property attribute. So the getter, sometimes called getter, which allows reading balance as an attribute. So you can also define the balance, and this method, the balance, it defines the balance property. So I'm having indentation issues, but I will fix once I'm done. So we can also define a deposit, so self and amount. So we can also define some public method to safely modify balance. So for example, if amount is greater than 0, then you can add some amount, and as well you can also return the deposited amount as well as new balance to our account whenever we do a transaction. So you can also define withdrawal. For example, if you withdraw your account from your account, then the account should be updated automatically. So this is a public method to safely modify the balance after withdrawal. So therefore, if amount is less than 0 or is less than or equal to the actual balance, then amount is equal to, we need to remove some amount. So which means we want to define withdraw amount, and then it will give you the remaining amount. So let me fix the indentation, and I'll be back to run this code. So after fixing the indentation, this is our final codes for our bank account using encapsulation method. So this bank account, a person can view the balance which is protected by the owner, and as well the person can deposit which is public, and the person can withdraw as well, which is public, and the account can notify the owner if the amount is insufficient, so the person will be unable to withdraw the amount from the account. So he or she will be prompted, for example, to deposit something before withdrawing. Hi guys, now it's time to manipulate our bank account that we've just created. So for example, account is equal to bank account, and now the owner of the bank account is Tom and has a deposit of 1,000, for example, USDs. So if we print account dot owner, it will give us owner's Tom, and account dot balance will give us as 1,000 USD. So using at property method. So and you can also print account dot deposit, so which will means that 500 USD will be deposited into into Tom's account, and we can as well withdraw some amount, such as account dot withdraw 200 USD, which will give us output as withdrew 200 USDs. A new balance will be 1300 USD. So you can also try to access private attribute directly, which won't work. So from your side, you can try printing account._balance. This one will raise an attribute error. It is private, so it will throw an error. So let me run our program and confirm what is happening. Let me run. So by ops.py, and this is our result, that the account is Tom, or the account owner is Tom. We have the balance was 1000 initially, and the deposit was 500 USDs, which turned out to be 1500 USDs. And then Tom went ahead and withdrew 200 USDs, and now 200 minus 1500, you get 1300 USDs. I hope guys you understand. Now you can manipulate this bank account, and you can also do more other examples. So let us move ahead. Hello guys, in this section we're going to look at special method called Danda methods. And these methods allow classes to define their own behavior or properties for built-in operations. So for example, you can have a class of vector, and this one will demonstrate operator overloading with special methods. So for example, we define our method as self x and y. So and self.x will be x, self.y will be y, and we also have another method of define add that self and taking other parameters other. So this is an add a parameter or overloading operator. So it means variable vector1 plus variable plus vector2, and we get our result. So if we can return, so I'm having generation issues, but I'll fix them once I finish this program. So we're defining a subtraction method as well, self comma other. So this is an overload method or operator which takes vector1 minus vector2 and will return vector as self.x minus other.x comma self.y minus other.y. So you can also define another method called mul for multiplication, and it take self and a scalar. So the scalar can be any number between 1 to 9 or 0 to 9. So for overload times operator, that is v1 times v2 for example. So you can also return vector self.star scalar comma self.y star scalar. You can also define a star method that's overloading string representation, that is star v1 for example for vector1, and you can also do for vector2. So returning vector self.x comma self.y. You can also look at length overloading or length operator method, so which means we are overloading length function and it will return the magnitude. And you can also return init, which means self, and this it will give the parameters as x squared plus y squared, and then we multiply by 0.5, or we square root them. So you can also define the equal sign, so to determine if x hand side is equal to what's in the right hand side. So let me fix the indentation issues and then come back with more explanation. Hello guys, now we want to use our vector class. For example, v1 is equal to vector 1 comma 2, v2 is vector 2, and you can print vector 1 plus vector 2, which output will be 4 and 6, and print vector 2 minus vector 1, the output will be 2 comma 2, and you can also print vector 1 times 3, you get 3 comma 6. At the same time, you can print the length of vector 1, you get 2 rounded from 2.236. so you can also print vector 1 is equal to vector 1 comma 2, and the output will be true. So this is the way to go from our special method. We have a class vector which has some methods. We have add, subtract, multiply, string overloading or string representation, length, and equal method. So we've also tested all of them using this vector class. I hope you understand the special method. So you can also do further research. So let's move ahead. So guys, we're heading to our summary of module 5, and the following are our take. So classes are blueprints for creating real objects with attributes, and methods. Remember, methods are behaviors. So, and inheritance simply create new classes that extend the existing ones. And on the other hand, polymorphism is just a way to differentiate classes from one another, or in which we can differentiate classes. Different classes can be used interchangeably. Whereas encapsulation is a way to protect internal state from direct access. While special methods are used to customize the behavior for built-in operations. So these are your practical ideas. Create a book class with title, author, and page count attributes. Number 2, you can also make a library class that can store multiple book objects. And number 3, you can also add methods to check out and return books. Number 5, you can implement the star method for nice printing. Let us meet in module 6. I wish you all the best. Please subscribe to our channel. Thank you.